All right, learning science by doing science. Now, one of the things that I've always been frustrated by with my students is they often will think that science is about knowing facts and knowing like what this is versus this or how this concept works. But in reality, science is about learning and understanding. It's about asking questions and getting answers and collecting evidence to support one idea or the other. And we do this all the time, right? What's the best cell phone out there? Well, this one has this feature, this one has this feature, this one has this feature, and we collect data. What's the cost? What are the features? Those kinds of things to make a decision, to make a determination as to what is the right one for me. And so science is like that too. And the Next Generation Science Standards, or NGSS, tells us that students should use the tools of science to learn the science itself. And that's not often how it's taught. I know when I was growing up, I was taught very concrete things from the beginning. So, for example, I was taught that when you have a chemical reaction, it changes from one substance to another, to a different substance, right? And the properties will be different. Great, awesome. Doesn't mean anything to me, really. I mean, it kind of did, but it's not until you have the practical aspect or the practical understanding of it that it really makes sense. So the new way of teaching it would be to have students they have two different samples of something, let's say, and this is one that I've done in my classroom, soap and fat, right, Crisco and just a bar of soap, and look at them. Say, hey, they're different. This one's soft, this one's hard. Okay, great. And then you do melting point. These have two different melting points. And then look at color. The color's slightly different. You can go through all these different properties of the matter. And at the end, be like, yeah, they're different. They're different entirely. And then you learn later that you can make soap from fat. And they're like, what? And it's just kind of crazy. But the idea is you don't tell them the answer out of the way. You kind of give them the tools, allow them to conduct investigations, allow them to ask questions, all these things in order to come to the understanding on their own. It's much slower and it's much better. So I encourage you to do it. That's what the standards tell us to do. So very, very easy. And this was a hard practice for me to get out of. But when a student is explaining what their thinking is, I would often say, right, that's exactly what it is, or not quite, let's try again, instead of saying, what makes you think that? So right or wrong, right? So if I know that they're talking about the water cycle, for example, and I say, like, the question is about what is evaporation, and the student says, oh, well, that's when liquid water on the ground heats up and then goes into a gas state. Right? Great. Awesome. You know that. I could say, right, that's exactly it. Okay, moving on. Or, and maybe that's not a great one because vocabulary is a little different, but like, how does water go from the lake to the clouds? Might be a better one to say. And the student might say, well, it evaporates. It goes up into the clouds. Great. But what I want them to be able to do is to say, I want to be able to say things like, well, what makes you think that the water from a puddle on the ground goes up into the cloud? That's a much harder question to answer. And it requires them to have collected some kind of evidence or have some sort of knowledge about how that works. Maybe they say, I've seen the steam come off of a roof or off of the pavement before after a rain and the sun comes out. And I can actually see it going up in the air. Bam, evidence. Awesome, right? I don't want them just to know facts. I want them to have a really good, concrete, visual understanding of what's going on. What's your evidence for that, or what makes you think that? So let's try to avoid saying right or wrong as much as possible. Vocabulary is one of those times where we do say right or wrong. So is that evaporation or is that condensation? Well, those are two different things. And so if we're going to speak the same language, we do need to have an agreed upon definition. But here's the important part. It's far more important to have students not know the vocabulary and understand the concept first. So again, if we're talking about evaporation, then we can have a glass in a container heated up, see the steam come off, and have the water all disappear, and then to have the students talk about that, what's going on, how's this working, and then eventually they understand that water can leave the liquid form and go up into a gaseous form. Then we introduce this concept of evaporation because it gets so tedious to say, well, when the water goes up into the air and goes in, it's like there's a word for it. It's called evaporation. Great. All right, let's use that word now. And so it's better for vocabulary retention if the students have the concept in their head before a word is attached to it. So try not to start with your vocabulary. Try to have that vocabulary at the end. All right, learning science by doing science. Take care and good luck.